This tutorial is about statistical interaction. And what I'm going to do is I'm going to start with a fairly sort of silly example just to try and grasp the concept. And then I'm going to look at a more genuine social media example. Now, the first thing to understand about statistical interaction is it involves the relationship between, I'm going to use the right tool, variables. And in statistics, there are usually two kinds of variables that we talk about. There are the independent variables and dependent variables. Now, usually the dependent variable, not always, is the variable that you measure, a measurable variable, and the independent variables are variables that you manipulate in some way to see their effect on the dependent variables. So the independent variables, it's a bit of a misnomer really. Maybe it would be better if they were called the non-dependent variables. They're the variables that don't depend on anything. Normally, you're interested in the effect of the independent variable on the dependent variable. In statistical interaction, though, there are two independent variables that we're interested in their effect on the dependent variable. So let me give you an example. I want you to think about a shotgun. I'm not going to draw one because I'm terrible at drawing shotguns. And think about a measure of the effect of a shotgun. What is the effect of a shotgun? Well, either you are dead or you're alive. That's my dependent variable. And the independent variable, the main independent variable I'm interested in, is what happens when you pull the trigger. So trigger. Now, if you have a shotgun and you pull the trigger and the gun's pointing at somebody, if there's a bullet, a shot in the gun, then you might change the state of this person from being alive to dead. But if there's no bullets in the gun, then it won't change their status. So there are two independent variables that I'm interested in. One is whether you pull the trigger, and the other one is whether the gun is loaded with shot. So for the loaded variable, there are two possible states: unloaded and loaded. And for the variable of trigger, there are again two possible states: you've pulled the trigger or you've not pulled the trigger. So that gives us a table known as a 2x2 table, because there are two states of one variable against two states of the other variable. And it's the combination of these two variables that we're interested in knowing what the effect is on the dependent variable. So let's start with looking at the unloaded gun column. We know that if someone is alive and you point an unloaded gun at them and don't pull the trigger, then they'll still be alive afterwards. But equally, even if you pull the trigger, because the gun is not loaded, they will still be alive. Now move on to the second state of this variable. If you have a loaded gun but you don't pull the trigger, then the person will still be alive. But if you pull the trigger with a loaded gun, then the person becomes dead. So what you can see is it's only when the two variables combine, the pulled trigger and the loaded state of the gun, that you have a main effect of the person changing from alive to dead. And this is an interaction. Loaded is one independent variable, trigger is the other independent variable, and when the two variables combine under certain conditions, it has an effect on the dependent variable. But when they're not combined under those conditions, it has no effect. So this is an example of a interaction where there is no main effect. It's only when the two variables combine that you have an effect on the status of being dead or alive. What I want to do is draw a graph of this effect, and normally when you draw graphs there are two axes, so I draw the axes, and on the y-axis we're going to use the dependent variable, which for want of a better term we call aliveness, and there are only two states, so we can mark on the two states. There's the state of being alive and the state of being dead. And along the x-axis we're going to plot the independent variable. There are two independent variables, the state of the triggerness, and the state of the bullets being in the gun, loadedness. In this example it isn't obvious which one you would want to choose, so I'm going to choose loadedness. And there are two states of loaded. There is unloaded and loaded. Okay. So, what do we do next? Well, there's another variable, and the other variable has two states, the trigger being pulled or the trigger not being pulled. So we're going to draw a separate graph or a separate line for each of those states of the second independent variable. So I'm going to start with the not pulled state. So I'm just going to put a key, not pulled. Okay, so when the gun is unloaded, the state of aliveness, if you haven't pulled the trigger, is that you're still alive. And if the gun is loaded but you haven't pulled the trigger, the state is that you're still alive. So the graph goes from unloaded to loaded, no change in the state of aliveness. Now what about for the loaded, for the pulled case? So I'm going to do the pulled one in a different colour. Let's do it in red. So this is the triggers being pulled. So when the gun is unloaded and when the gun is unloaded and the trigger is pulled, then the person is alive. And when the gun is loaded but the trigger is pulled, this time the person is dead. So in this case, the aliveness, the state of aliveness changes from being alive to being dead when you change from being unloaded to being loaded and pull the trigger. Okay, so the red line indicates one of the two states of the pulled variable, and the blue line indicates the other state. And one of the things you notice about this graph is that these two lines are not parallel, and that's a visual clue that there's an interaction. Because when the two combine, then this line diverges. I'll say that again. When we combine pulledness with loadedness, the two lines diverge. And that's telling me that it's only when you combine two states of the independent variables that you get an effect on aliveness. The two variables interact with one another to change the state of being alive. So now I'm going to look at another example of an interaction, this time from some social media research, Dykman's et al. 2015, and they have two independent variables. So the first independent variable we're going to look at is the intensity of social media use, and the second independent variable that they consider is, for the want of a better term, customness, whether you're a customer or not. And the dependent variable, the variable that we're going to regard as being measured, is engagement. So we end up with our 2x2 design again. So I'm going to put engagement as the dependent variable. So the rows and columns would be intensity of social media use and customerness. There are two levels of customerness: being a customer or not being a customer. And we're going to imagine two levels of intensity: low intensity of social media use and high intensity of social media use. And then we measure engagement, and I'm just going to look at their statistics, try and guess at what the values are. So for low intensity and being a non-customer, the level of engagement is, let's say, 0. And for high non-customers, the level of engagement is about 0.2. And then if we move on to being a customer, for low intensity, the level of engagement is 0.6. And for high intensity, the level of engagement is 1.6. So there are values. You can see in this case that when you move from low to high intensity, the numbers get larger. So intensity is having an effect. And also, if you look at going from non-customers to customers, again the numbers get larger. So there are two effects, and they're known as main effects. Two main effects. One is that being a customer increases engagement, and the other is that increasing the intensity of social media use increases engagement. But the effect that I'm interested in discussing now is the interaction effect. And the easiest way to see whether there is an interaction effect is to draw one of the graphs. The interaction effect would be that when you combine being a customer with high intensity, the level of engagement goes up more than you would expect by either one of them alone. So to draw the graph again, we put the dependent variable on the y-axis, and the dependent variable, if you remember, is level of engagement, and that ranges from about 0.2 here to 1.6 up here. I'm going to put another few values on, and we've got 0.6 around here, and obviously 0 here. Good. And the x-axis then is one of the two independent variables, and this time the independent variable that I'm most interested in is intensity. So I'm going to plot intensity of social media use along this axis. And again, there are two levels of intensity. So we've got the low level and the high level. And we're going to plot two lines, one for each of the two states of the second independent variable, customer-ness. So I'm going to start with being a non-customer. So if you're not a customer and the intensity is low, then engagement is 0. So that's there. And if you're a customer, not a customer, and the intensity is high, then it goes up slightly to 0.2. So we draw a line between those 2 points. So I'm doing my key again. So this is non-customers. And then I'm going to change the colour back to blue. And this time we're going to draw a line for customers. So for customers at low intensity, the level of engagement is 0.6. So we're here. For high intensity is 1.6. So we're here. Drawing those points up, slightly wonky line. And now this time notice that the two lines are not parallel. And that indicates to me that there is a statistical interaction between being a customer and level of intensity of social media use.